Happy morning to one and all present here, and welcome you all. I welcome you all to the sixth day of the Phase 2 induction program. Looking forward to a wonderful day. I'm sure even you all are looking forward for a wonderful session. I take this opportunity to welcome all the faculty members of B&M Institute of Technology, Director Professor T.J. Ramamurthy sir, Additional Director S.Y. Kulkarni sir, our Dean Ishwari Anmani sir, and our Principal Krishnamurthy sir. With that, I also take this opportunity to welcome all my dear students. Today with us, we have a very well experienced Madhu Hosadurga, Global Director, Data Science, Robotics and Blockchain, Schneider Electric. Now, Mr. Madhu, he has a total of 18 years of working experience in digital technologies such as data science, analytics, and big data engineering. He has helped many Fortune 500 companies in setting up their digital strategy, roadmap, competency, and delivered many industrialized AI, ML, and robotic solutions. He has founded a startup and achieved a revenue of 2 million within a span of 2 years of its inception. He has a vast experience. He has worked in General Electric, Wipro Technology, Oxaltics consultancy services, and currently he is Global Director, Analytics, Robotics and Blockchain in Schneider Electric. He is going to talk to you regarding the emerging areas of engineering today. Sir, we are honored to have you here today with us. Students will be able to chat and they will be able to ask their questions at the end of the session. I welcome you again and over to you, sir.
Hey, first of all, thanks Praveen and to all the members of B&M IT for giving me this opportunity today. Could you confirm if you can hear me well, Praveen?
Yes, sir. Of course, we do.
All right. Okay. So again, thanks for giving me this opportunity today. So hope this session adds value to your students. And again, as Praveen said, I think you can type in your questions, and probably I will even pause sometime in between if you want to ask any specific questions over the voice. We can do that as well.
And sir, as I told you, they'll be allowed to ask questions at the end. They can type in their questions in the chat box. At the end, they can even talk to you. They can discuss with you. Yeah.
Okay. And also sometimes like I hear a bit of a lag with the camera on. If in case that continues, I may just turn off the video, but we can continue the session. Okay.
Yes, sir. Not a problem, sir.
All right. Okay. With that, let's get started. Okay. See, I understand the audience here is mostly from the first year and from different streams of engineering. Again, it's a great opportunity for me to be addressing such a diverse group here. And I also believe this is a great opportunity for me to help you guys leverage this engineering course and contribute to the nation as well as to the engineering field as well, right? So before I get started on the digital tools and technologies, the emerging ones, I wanted to address this group and tell them that you guys are first of all lucky to be in this era because engineering probably is at its peak, especially the digital part of it, right? And you guys are all lucky to be entering engineering at this peak time. And also there's a huge transformation happening from the digital front. Again, it's a great opportunity for all of you to leverage as well as contribute into this new emerging sector. Okay, and the good news is these tools and technologies what I'm going to be talking today are agnostic of any engineering stream. Okay, so you need not worry if you are from civil engineering or mechanical. It's not that this won't be applicable to you. So these tools are agnostic to all the streams, so which is good news. And secondly, I also wanted to tell you guys, see one thing which I feel we as Indian engineering institutes lack is in preparing students for an entrepreneurship journey, right? So most of us see engineering as a degree to get in, get our course done, get the certificate, and then most likely look for a job or, kind of get into a next level of academics or something like that. But I think I would like all of you to rethink this, especially the students, right? Because if you really look at elsewhere in the globe, engineering is probably the most practical education one can get. And most of the successful startups today have come out of, similar engineering colleges elsewhere in the world. Okay, so it's a great opportunity for you guys to be in the engineering today and leverage the ecosystem of startups around you and make our nation proud. And I'm pretty sure if all of you attempt, we will have many more success stories in a nation like India, right? So with that angle, I'm going to touch upon some of the emerging technologies, which I believe, if you are interested, you can uh, hello, am I audible, Praveen?
Yes, sir. Now you are.
Okay, I
There was
think
a
there
small lag.
was.
Now you are
Okay,
audible,
okay.
sir.
Maybe I'll turn off the video because it's causing some lag. So let me just try that.
Sure, sir.
I hope it's better now. Okay. No, I was just saying that it's a great opportunity for all of you to apply technology as you study. Do not wait for finish of the course for application of what you study, right? Treat it like a lab. Your engineering course is a lab for you. It's an incubation center for you where you can try your ideas. Do not wait for the course to complete before you experiment things. So I think that's one thing I wanted to say before I get started. Okay. All right. I would start, talking about, the digital transformation which is happening around us. Now, why it is important is, while you are studying as well as when you come out of your engineering course. So this is what most of you would be working on, right? This is where you will find opportunities and jobs. So it is always good to know well in advance what is that you're going to be doing, right? So the next, I would say 2 decades or so is all going to be digital transformation. Okay. So the first question which arises or good to understand about digital transformation is it an evolution or a revolution? Right. So the question is important because it emphasizes the need for all of you to be digitally equipped. Okay. So just to draw some parallels, first of all, it is a revolution in my view because it is completely changing, the way we do business and we do, live in our day-to-day life, right? So first of all, let me draw some parallels to the industry revolution, which happened probably beginning of, the last century. Many of you probably, are not aware of the industry revolution, but at some point in last century, just like, the digital is emerging today, industry revolution started emerging, right, in 1920s or 30s and stuff like that. So that is where the factories started coming in, the manufacturing boom happened, automobile boom happened. So a lot of things followed one after another, right? But actually, what led to that industry revolution? Okay, so the answer lies in a simple engine, a simple engine actually led to the entire industry revolution. So what is an engine? An engine is something which can uh, perform physical activities, fueled by some energy, right? That is what engine is all about. So it can basically replace animal and human laborious effort, which was earlier happening through machines. So now that machine transformed different sectors of business, right? First, it transformed the way we did agriculture, right? What was plowed using animals became machines, the tractors and the earth movers and so on and so forth. It changed how we manufacture things, right? Again, now with your big machines, you're able to do a lot more, be more productive, and replace human and animal efforts again. It changed the way we transported things, right? The cars got introduced, the locomotives got introduced, the buses and many other things, including the airplanes and the rockets and whatnot. And then it also changed utilities. And these are like few examples. It has changed every sector of business, including healthcare, the banking, the financials, right? So these are some of the examples of what industry revolution did, and it just took birth with one small engine which could convert a fuel into a mechanical energy. Okay, so now let us draw parallels to what is digital revolution. Okay, uh, I hope it kind of gives you some parallels and an analogy. Okay, so just kind of summarizing this industry revolution, what it did, it basically replaced human efforts by the machines. And then the bigger the machine, obviously it could do a lot more. And then with each evolution, there was obviously an improvement in the industries, right? For example, the car has evolved, multiple iterations, and today the car what you see is a much better version of what was there, let's say 50 years back. Okay, in fact, today as we speak, we are at the fourth, I would say, evolution of industry revolution, right? So this is why we keep referring to industry 4.0. So if you are coming from mechanical or any other manufacturing industry side, you would start hearing these words, industry 4.0. Okay. All right. So now let's look at similarly what is happening in digital, right? Like in industry, an engine changed everything. Let's see what digital is doing. Right, so now an engine basically changed how the car was built. Now let's look at it. So the same engine, which is now what we call as a central uh, computing or processing unit, CPU also referred to as, now that is the new engine which is helping us build the digital platforms, right? See, for example, if you look at this car here, which was generated by the mechanical engine, what I talked about, it was a very pure mechanical platform. But today, the cars which you're going to be driving around are more of a software platform. They are no longer a mechanical platform. While obviously it has the chassis and the body, but the cars can change with a simple software upgrade, right? And the fuel economy and everything else, including the transmission of the company, is digital. It's driven by the software, right? That is what is happening in the digital revolution. So what was machine which was meant to replace people, now the digital is about replacing machines itself. We want to go virtual, right? We don't want like the big engines. We don't want the big, transmission box. We want to go digital. And if you really look at the new age cars, it doesn't have an engine because most of them would be electrical, would be driven by software, and they would not have a transmission because again, software controls, the whole transmission of the electric motors, right? So this is what digital transformation or digital revolution is all about, which is replacing machines with the virtual world. Okay, so kind of giving you an analogy from what happened in the industry revolution to what is happening today as well as what's going to happen in the next couple of decades. Okay, so this digital is the new engine. That is why people keep saying data is the new fuel, right? If you look at mechanical motor or an engine, it took petrol or diesel or some kind of a fuel, but new CPUs need only data. Okay, so that is why data is referred to as the new oil everywhere. Okay, and this is what digital revolution is doing. It's changing everything as we speak. So let us take few examples of digital revolution which is happening around us. Okay, well, I don't know how many of you recall, a desktop, 15 years back, not very long back, but if you just go back 15 years, the desktop, the top of your desk at home or in office looked very different, right? Usually it used to have like a proper desktop with a monitor and a keyboard. It used to have like a fax machine. It used to have some kind of hoard where you could you know put your pictures, and you used to have a physical calendar. So this was like just about 15 years back. You even used to have like a radio and stuff like that. But look at what has happened in the 15 years. Everything here, which was supposed to be machines, has just become virtual. It doesn't exist anymore. It's all in like probably a software. That's why I keep saying we are moving into a virtual world, right? So none of this today exists, and it is all part of your either a phone or a small laptop, right? In fact, the phone is as good as a laptop today. Okay, so this is how digital revolution has changed our day-to-day life and replaced machines. Okay, another picture. In fact, if you go 20 years back, everything this guy is holding was the gadgets we were all using. The tape recorder, the VCR, and then you have the CDs. And I'm pretty sure many of you probably have not even seen the CDs nowadays, right? But CDs used to be big. We in fact, when I used to go to engineering college, we used to carry these floppy disks and the CDs, which used to have like our lab projects and all that stuff. Today it's all in like pen drive, right? So we used to have like calculator. We used to have so many physical machines which would assist us on a day-to-day basis. Now it's all gone. None of this exists. It's all in your pocket, right? So this is a great example of how digital is transforming physical world into a virtual world, right? So this is very important for all of you to understand, because you're going to be contributing to this industry very soon, right? And also use this opportunity to experiment, build products as early as while you're doing the engineering, right? Apply these while you're studying. Okay, so this is another example. And then let's also look at how this old digital is transforming every sector, irrespective of where we come from. Uh, if you actually, remember in offices as well as in everywhere, we used to ask people for assistance, right? We used to have someone, send us emails, someone monitor our schedules, someone to help us with our day-to-day course. So now that is replaced by a simple digital assistant like a Siri or a Google OK or Alexa, any of that, because that can do what a physical assistant used to do just like 10 years back. Right now, nobody has personal assistants because everything is doable in the phone itself. Right. So digital transformation or revolution has changed how we do day-to-day course. Okay. Similarly, I'm pretty sure all of you are aware how digital is transforming the taxi industry. Right. See, these are some of the examples I'm giving you how digital revolution is changing the different sectors, just like how industry revolution changed all the sectors, right? So I'm just still drawing some parallels here. So as you know, like Uber and the Ola, what you use today did not exist 5 years back, right? We used to still, wait at the road, waving at the taxis. If they stop, we are lucky. Otherwise, we had no options. Otherwise, you go to the main road and wait for cab or a auto or a bus or whatever, right? Today you can call a Uber or Ola sitting at your couch and exactly track what time he's going to arrive, right? So that's what digital revolution is doing. In fact, it's going even further one step. You're going to be having self-driving cars very soon, wherein the taxis would not have drivers also, right? These will be self-driving cars. They would come to your home, pick you up, drop you, and you pay through the phone and job done. So no human involved. Okay, so this is where digital transformation is taking us. Similarly, in fact, if you go 10 years back, everything was brick and mortar. Like you had to go to a shop to buy things, right? Whether it's grocery or even other items like apparel or electronics. Today, nobody goes to shop because it's all digitally available in e-commerce. Just a phone away, you can find whatever you want. You can order whatever you want. Gets delivered in an hour or two or maybe a day. Right? This is what again digital transformation is doing. It's replacing physical world with the virtual world. And I'm pretty sure earlier we used to see big billboards of movie posters as well as a lot of endorsements which used to happen. Now people are not actually using these billboards, rather they are posting it in social media like Facebook and Twitter and Snapchat and whatnot. Again, the advertising industry is changing with the digital revolution, right? In fact, these going to be our things of past very soon. Advertising in the big billboards. Similarly, the books are gone, right? Today we all talk about digital copies. So usually I haven't seen people now even buying physical books. It's all digital copies. Similarly, theaters are gone, right? In fact, maybe even pandemic is further fueling it. But today we are talking about Amazon Prime and Netflix, OTT platforms. So the physical theaters are going to disappear very soon. So this is again what digital revolution is doing. Watches are gone. It's all soft watches, or in fact, probably it is available in your phone itself. The music systems are gone. Classrooms are gone. Actually, this is a great evidence of me speaking remotely over a computer to address, I don't know, hundreds of students. And I don't need to be in a physical classroom to do this, right? This is a digital revolution. Me sitting, kilometers away and still addressing all of you and could share my thoughts in a visual form as well. Similarly, the banks are gone. I don't know how many of you know or remember. We had to go to banks and carry our passbook and make an entry, credit, debit, and whatnot, wait in the queues. And most of you probably have not even visited bank because it's all available in your Paytm and GPay and whatnot. Right? That's again a digital revolution. Banks are going to disappear. The physical banks will be of the past very soon. Office spaces are disappearing, right? In fact, again, fueled by pandemic now, many people are working from home. We may not even actually need so many offices going forward. So that is what digital revolution again doing, helping people work from home, sitting wherever they are, right? The maintenance in the mechanical industry is changing with what we call as virtual reality, what we call as things like HoloLens. You will be able to maintain mechanical stuff or repair mechanical stuff sitting hundreds of kilometers away, right? You may have already seen virtual reality or augmented reality machines where you can wear a glass and remotely control the different machines, which are also IoT enabled. Anyway, I'll talk about IoT probably in one of the slides. So, and then currency is going away, right? So we are not dealing with physical currency anymore. So it's all digital currency today. In fact, we are probably even going one more step of going into decentralized digital currency, like the cryptocurrency, what has become a hype right now, right? Similarly, the camera industry gone. Nobody carries big cameras anymore. The maps are gone. Earlier we used to actually have maps. Now it's all part of your phone as a simple software, as a Google Map or Apple Map or whatever, right? So these are like some examples of what digital revolution is doing to different industry sectors. Okay, now you may understand why I say digital is agnostic of any engineering field. If you are a civil engineer, it's still applicable to you. If you are a commerce graduate, it's still applicable to you. If you are a computer science, it is still. If you are an electronics, it is still. Okay. Sorry. So this is an important topic for engineering graduates like you to understand and find opportunities where you can, let's say, find your own products. Imagine you building products in this early stage revolution which is happening. That's why I keep saying you guys are lucky to be in the early stage of this era, right? So in fact, I don't know how many of you follow the industries. All the old big companies, big organizations are now beaten by the industries which are just 10-year old. For example, Google is probably much bigger than, let's say, Tata Enterprise, which has been there for like centuries. Okay. Similarly, Facebook is much bigger. Apple is much bigger than General Electric, for example. Ford. These are all like gone now because the new age industries are emerging and they are disrupting the way things were done in the past. And you guys are lucky to be in the just beginning of this digital revolution. And everything you do is going to be a gold. Okay. So this is why I say apply the technology while you study. Do not wait for the job to apply what you learn. Okay, it's a great, amazing opportunity for all of you. All right, so what does that mean to the engineering streams or the organizations? You got to now reimagine how things were done, and you need to reimagine how you serve your customers. For example, assume if you are a civil engineer, at least in my engineering days, we used to carry those like big forgot the name, like you have those big scale and stuff like that which you carry to draw things, right? Now with the 3D drawings, do you really need them? So you need to reimagine how you can change the way we did things, right? Do we need to still do the same way? Not necessarily, because there are better ways to do it. So you need to reimagine, and that's an opportunity for you guys to reimagine and bring in new products and adopt new products. All right. So with that background of what digital transformation is all about, how it is disrupting, and the kind of opportunities all of you have, I'm going to talk about briefly on the information technology and the digital, and also I'm going to touch upon some 7 8 key digital tools which I think you should all be aware and probably even embrace and do things with them. Okay. First thing is, in fact, I get this question often. So what is the difference between IT and digital, right? Because last 10, 15 years, we were talking about IT everywhere. Now we are talking about digital everywhere. Okay. So as an engineer, all of you should have this clarity, right? I'm okay if, somebody outside of engineering getting confused with this, but as an engineer, you should have clarity. So let me clarify a bit for you guys so that you know when you address digital, you have understanding of what it is. First of all, it's important to understand what is information technology, right? Information technology is a technology. It's an engineering. It's a platform which can take data, store data, compute data. That's all IT is all about. Information technology is about taking data, storing it, and computing it. Okay. Now, using this technology, you can build different types of products, right? Different types of applications. Basically, you're applying technology for something meaningful. That's why these are called applications, right? Application of a technology. So last 2 decades, we applied information technology for what we call as process automation, meaning we wanted to automate different business processes. For example, it could be, let's say, talking about college example, it could be a simple, let's say, collection of a fees and generation of, let's say, an all ticket, right? If that was done physically earlier, IT helped us automate that. You can pay online, and then on the other side you get let's say an all ticket. So that was known as process automation. And most of the ERPs like SAP, Oracle, IBM, their focus last 2-3 decades was to build these process automation tools, also known as ERPs, Enterprise Resource Planning. Okay. However, digital application is a new happening. It's a new area which is emerging, in which this is not just about automation. This is about going virtual, replacing physical stuff. While process automation was more of keeping the machines in place, kind of assisting people do their job better, digital is all about going completely virtual, changing the way we do things. For example, if you look at process automation, right? So let's say we take Tata as an organization. They have like lakhs of employees, and it's not easy for humans to manage so many number of employees. So they may have a payroll system, for example, which would generate payroll every month, credit salary to every employee. So that is process automation. Okay. So now in digital, it could be probably replacing those human beings with a robot which can do the job, right? Doesn't mean we are saying people are going to lose job. They can do something else, but things which are repeatable, things which are very predictable can be done by machines, and humans can be used for something which is a lot more sensible than what machine could do, right? So this is the difference between digital and process automation and IT. People just use these terms interchangeably, but you as an engineer, you need to have proper understanding. Information technology is a platform, and then you can have multiple applications. Okay, and this is the next future, which is digital application. Okay, so moving on. So these are some of the key tools within the digital, which all of you should not only be aware, also should start applying them, start using them in your engineering field, right? See, you guys are at such an intersection. You understand engineering, the problems of engineering, and you are aware of the technology which can solve the problem, right? So it's a great combination today. This is why I insist engineering students to be in the forefront to apply digital technology in the engineering field. Okay, so some key tools. I'm pretty sure you may have heard artificial intelligence everywhere nowadays. I'll come to that, and that's one tool. Then you have robotic process automations, low code, no code. You have big data platforms. You have Internet of Things. You have blockchain. You have cloud storage computing, cyber security, augmented reality, virtual reality. Mobile itself is part of the digital revolution, right? So these are like some key tools which are very much part of the digital revolution, and important for all of you to be aware as well as use them. Okay, or maybe Praveen, before we go too far, you want to like take any questions, because now I'm going to be
Okay.
deep diving into each of these boxes.
Sure, sir. Sure. I will allow the participants to unmute and
Sure, because
you can.
I don't want them to forget the questions, because it's important they
Sure.
understand.
Sure, sure, sir. Sure. Yes, sir. I have allowed the participants to unmute. They can ask their questions if there are any.
Sure, please. Or you can chat if you are comfortable, or whichever way. Yeah, please go ahead.
Excuse me, sir.
Please, yep. Amol,
Sir,
go ahead.
my name is Amol Krishna. I'm from CSE. Sir, I just wanted to know, you talked about how the revolution, how we're facing a digital revolution. So, what is your opinion on cryptocurrency now, sir?
As if my opinion matters, but yeah, I'll still give you my opinion. See, cryptocurrency is basically, a decentralized finance, right? It's all about. See, earlier we had centralized currencies which were centralized for a given country, and also we had centralized currency for the entire world. I mean, dollar was considered the global currency earlier, but now that's being changed by decentralization, right? Future of cryptocurrency, I think it's more a political decision than a technology decision, because obviously there are advantages and disadvantages of cryptocurrency. The advantage is that it's completely decentralized, nobody controls it, very transparent, traceable, trackable, immutable, and all that stuff, right? But on the disadvantage side, now nobody controls is a big problem for the government, right? I'll give you a simple example. Assume today you have few bitcoins. So assume I invest in India, I go withdraw in US. Where should I pay my taxes? Should I pay in India or should I pay in US? And who controls it? So this is where regulation and countries are facing a problem with this, a global currency like cryptocurrencies. And this is where governments are a bit concerned. Now, for example, recently Turkey banned exchange of cryptocurrency, and I'm pretty sure many countries would join. So that's why I say it is more of a regulatory issue, political issue than a technology issue. So only time has to tell whether it will sustain or it will come under a lot of regulation. However, see, blockchain as a technology has a lot of applications. Cryptocurrency is only one such application. Okay, irrespective of what happens to cryptocurrency, a lot of blockchain applications would emerge. Already coming up, there are way too many blockchain applications, and they're going to stay and they're going to revolutionize how we do day-to-day things. Okay, I hope that answers your question, Amok.
Yeah, thank you, sir.
Welcome. Anybody, any other questions? All right, I'm just using this break to, get some water also. So Praveen, what are the branches you have? Sorry, I don't know, like
So
the
we have
new
got
addition.
mechanical, yeah, we have
Okay.
got mechanical, electrical, electronics and communication, AI and ML, and we also have CSE, sir, and ISE.
What was the one before you said ISC? I mean, what was that? GSC, is it?
CSE, sir, computer science.
CS, computer science. Okay,
Yes.
okay, good. All right, not much has changed. I think only AI ML is added as the new
Yes.
stream, I believe.
Yes.
Okay, I think maybe, they should have probably called it digital instead of AI ML. Anyway,
So
good,
there's
at
a
least
question
some
in the
changes.
chat box.
Sure, I can't see that. Maybe you want to read it out?
Yeah, I'll read it out to you, sir.
Okay.
What are the industries that have survived, or that will probably, is the question, that will survive the digital revolution?
See, survival of any industry depends on how prepared they are and how they are able to adopt themselves, right? So there are many organizations. For example, Schneider Electric, if you look at, right? See, we were a very core manufacturing company till about 2010. In fact, 2012 is when we started what we call as industry automation, right? A 150-year-old company which was completely into manufacturing, started industry automation as a business offering, right? So now we are leading industry automation, which is nothing but digital transformation. We are using IoT technology to automate the different manufacturing industries, right? So this is a great example of how an 150-year-old company changed its business model to adopt and cater to the new digital area or era. Okay, so that's one example. Similarly, there are a lot of companies who are, you know, much advanced in terms of adoption of digital technology. There are companies which have collapsed also, right? There are many organizations which have completely gone out of the map just because they were not able to adopt. For example, retailers in let's say North America, the big ones like with 50 to 100 billion dollar revenue have all vanished. They don't exist anymore today. Like Macy's, and then there are many more in US, for example. Even in India, the most of the brick and mortar businesses have suffered a lot. Who would survive is a question of how good they are in adopting to the new digital technology, right? So who will survive? I mean, it's a difficult question, but anybody who would adopt would succeed and emerge successfully outside. All right. Any other questions in the chat, Praveen?
As of now, there aren't any, sir.
Okay, so let me come back to the topic again. All right. So before I jump, okay, so let's also take a few minutes to understand where digital is being applied. I'll give you some examples. Okay, so for example, in supply chain, right? Supply chain is the most complex business process as of today, mainly because of globalization, right? You may be aware how much impact pandemic has caused just because we are not able to import and export, right? So supply chain is the new emerging business sector, very complex one, and many of you actually may end up in this space because going forward it's going to be all supply chain, right? Managing things from here and there because of globalization and because of digitization as well, right? So in supply chain, what's happening? For example, in big warehouses of like Amazon or Apple, for let's say a 5,000 square feet of warehouse you may have, you will hardly have two or three people managing it. What that means is most of the business operations are managed by actually robots. Okay, so there are like robots who would do what otherwise humans would do, and they can like pick an order, they can sort an order, they can load them into truck, and then the truck can actually automatically deliver to the destination. Similarly, in automobile, again, everything is changing about the automobiles, right? As I also mentioned earlier, we are moving away from physical engines and transmissions and even oil based fuel into more digital car platforms, right? With the self driving aspect, I think the whole automobile would change, right? You would not buy a car to drive, you would buy a car just to commute. Okay, and you can probably change car just by upgrading your software. Okay, so similarly, healthcare is changing. For example, in pandemic, how we are able to, get the vaccine so early is because of application of AI and simulations in testing in a proportion which otherwise would not be possible, right? So there is a big play of AI and digital tools in today's COVID vaccine. Manufacturing is changing as we speak. As you can see, most of the plants today, manufacturing plants, have hardly, few people who are operating. Everything else is already automated, right? And this is where digital is being applied. Banking is changing as we speak, with digital currencies, with dynamic insurance policies. It's all changing as we speak. In fact, we're going to be soon in an era where your insurance premium of, let's say, car is charged based on how you drive, how fast you drive, or how disciplined is your driving. So that's going to be a reality in 1 or 2 years, maybe. Similarly, your health insurance would depend on what is your lifestyle, right? So that's going to decide whether you pay 1 lakh rupee per annum or 10,000 rupees per annum. So it's changing the banking industry. Obviously, as I think we earlier mentioned, digital marketing is also changing because of digital technology. So I just wanted to again bring a glimpse of fact that digital is business agnostic and also it is engineering stream agnostic. You could be in any engineering course. If you do not adopt digital technology, you will become also irrelevant, just like many companies, right? It's important for you guys to learn digital along with your main course. Okay. All right. So these are some of the examples again. Let me plug in this a bit. All right. So some real examples of digital technology applications in automobile, like self-driving car is a great example. Predictive maintenance of cars, in manufacturing, the entire inventory optimization, machine parameter optimization, predictive maintenance, visual inspection, which is nothing but computer vision or machine learning for vision. So in healthcare, cancer prevention, robotic surgery, clinical research, in BFSI, fraud detection, dynamic pricing, investment management, futures trading, in retail, the demand forecast. So everything, I mean, these are like, some real solutions which are already available in the market for people to use. Okay. So if somebody says, this is all future, they are bullshitting, because this is now. It is not in the future. It's already happening. In fact, it started even, I would say, a decade back. Okay. There is a bit of a noise, Praveen. Hear me, Praveen?
Yes, sir. I'll just check. Okay, I'll check. Check, sir.
Okay. Yeah, so these were like real life examples of digital applications and happening for many years now, just not like, they are future. So don't think that it is future, it is current. If you do not leverage it, you're going to be losing the opportunity. All right, so some of you may be, wondering what kind of jobs you can look for. Anyway, I think this is not even relevant at your stage, so I'll skip this. Okay. All right, so let me touch upon big data first. I'm going to cover, I think, two topics. One is big data. I'm also going to touch upon artificial intelligence. Out of like, the 9 or 10 different tools you saw, I'm going to detail into artificial intelligence. I'm going to detail into big data. If you want, I can touch upon any other topics if time permits. No worries. But before that, let's cover the big data and the artificial intelligence, right? Okay, so why big data has become very prominent all of a sudden, right? The answer lies in the fact that data is the fuel of digital revolution. We talked about that already. Okay. So when data is the fuel, obviously it has to be managed and monetized. Okay. So now the question is, as the name says, the data which is generated around the world through different forms and shapes is so big that it needs to be managed using advanced tools and techniques. And that is why, this big data has become very prominent, and the tools and technologies to manage this data also have become very prominent. And as an engineering students, very important for all of you not only understand and also able to build applications using big data, right? So if you do not understand big data, I think you will probably not become a big, good engineer afterwards. It's very important. I know it may sound rude, but it's like fuel for the new age engineer. Okay, so let's talk about a bit more about this big data. Okay, so big data constitutes what we call as three V's. One is the volume of the data we are managing. Second one is the variety of the data we are managing. And the third V is the velocity, meaning the rate at which this data is being generated and how we manage it, right? So you remember the three V's: volume, velocity, variety. Anyway, so I'll cover all the three. See, what do we mean by volume? Okay. See, as all of us now start using digital tools and techniques, that only means more data is getting generated, right? Assume if you are making this presentation over Microsoft Teams call, this is a data which is being recorded and probably stored somewhere. So imagine worldwide, so many MS Teams call happening, generating data. Okay. Assume you use your Facebook for 10 minutes, you're generating data. You travel from one place to another place, your GPS tracker keeps a track of, where did you go? So everything what we do today, we are leaving what we call as digital footprint. That means we are generating data every second, every minute, every hour. Okay. What that means, for example, see now we are measuring data in the zettabyte. So that's like one unit of measure. So here is the reference. For example, a floppy disk would be like 30 kilobytes. And let's say a zettabyte, like 1.8 zettabyte, was actually 2011's entire world data. That was that's 1 zettabyte, and it kind of gives you a perspective. Okay. So now in 2020, we are generating about 40 zettabytes. So look at this. In 2011, we had only about 2 zettabytes. In just 10 years, we have multiplied it by 20 times, right? That is how much data we are generating. Imagine, now everybody has a smartphone. So obviously everything they do would leave digital footprint. Okay, and this volume is expected to go to, let's say, around 175 or 200 zettabytes by 2025. Another 5 years or 4 years, you would multiply by another 4 or 5 times. So this is, imagine so much data getting generated. Now it's up to us whether we want to use that data, monetize, or we just trash it. And if you want to monetize that data, the data has to be managed using the right tool and technology. Okay. All right, let's talk about variety, right? So where is this data coming from? In fact, if you go back like 2 decades, the only source of data was business transactions, right? We had like ERP, like, SAPs and Oracles, and we also had a lot of business applications that would generate what we know as transactional data, including banking, for example. And this is what dominated last 2 decades and generated, assume, this is the proportion, like, the bottom one here. So this is how much we generated using transaction data. But then, let's say around uh, 2005 or so, we started contributing big in terms of human files. These are like, PDFs and the Word documents and, the web browsers and stuff like that. So we started adding further data into the world data, right? And this is when the PC was introduced and led to a lot of human files. And then around 2005, 7, 8, you got internet everywhere. right? With the internet, with the applications like Facebook and World Wide Web, browsers and stuff like that, the social data started increasing big time. Okay, so between like internet era and now, you can see social data surpassed all other types of data. Okay, and then now there is a new emerging sector we call as virtual era, right? The digital era. There is a new sector which is going to add data which is unprecedented. That is Internet of Things. Every mission going forward would be connected to each other, to the human beings through sensors. Okay, so now imagine if every mission is connected, every second it is giving you data, how much data we are talking about. And this is what is leading to the zettabytes of data. And it has just started. And imagine 10 years from now. And as we speak, 5G is going to be a reality very soon. Right, the fifth generation of internet. So today, most of your phones are enabled with 4G. With 4G itself, you were able to see movies, you were able to stream a lot of data on your phone. Imagine 5G coming into picture, which could be probably, I don't know, 10 or 20 times faster than 4G. Imagine what all we can do. For example, your refrigerator can order to Amazon directly when the milk finishes, and that's what we call as Internet of Things or connected devices. Right, your car can call, the service appointment, take service appointment when it reaches a certain kilometer. Right, so this is what we call as connected devices. And imagine the amount of data that's going to generate in the next coming decade. Okay, so this is what we mean by variety. So now obviously the velocity is nothing but the rate, the pace at which it is being generated. For example, every second, every 60 seconds, you have like 100,000 or like 1 lakh tweets. You got like 7 or 8 status updates in Facebook. I mean, I'm just giving you some examples, and there are like about 1,800 terabyte of data being generated every 60 second. Right, so this becomes like unmanageable very soon if the right tool and technology not used. Okay, so this is why the velocity has to be managed, and it's part of the big data technology. So volume, variety, and velocity. These are the three V's what big data is trying to address or manage. Because if this is managed, once your data is managed, lot of applications can be built. The digital applications, for example, right? And this is why it's important for engineering students to understand what is big data and how they can build applications on top of that. Okay, and you may wonder, actually, I'm a mechanical engineer, why should I build a digital application? See, you should build for your own stream. For example, 3D printing, it's nothing but a mechanical uh, industry product, right? 3D printing, or it could be robots are going to be used in the mechanical industry. So I'm not saying all of you need to go and build mobile apps. No, not necessary. Digital is not restricted to mobile app. Digital is applying technology to whichever sector you may be in. Okay, and this big data is applicable to all of you equally, and it does not discriminate, because today data is everywhere. All right, so this is big data and important for all of you to understand. Okay, and also just wanted to give you a glimpse of how the whole the data management industry has evolved with increasing the data size, right? So earlier in year 2000 and all, we used to have relational databases like Oracle, SQL Server, etc. And then as the data grew, we brought in new devices or databases, what we call as appliances, which was nothing but database put in a its own server, which is made efficient for storing big data. And then came in the Hadoop in 2005. This was the genesis of Google and many other search engines. And this kind of changed how we manage big data. And then today we are talking about cloud technologies. Anyway, I mean, not necessary for you guys to understand all this today. I'm pretty sure you would understand as you deep dive into database subjects if you already have. Otherwise, also if you are a mechanical student, it's okay if you don't understand the different tools and techniques, as long as you understand what is big data. That's very important. Okay. So databases have evolved, and the computation has evolved drastically in the last, I would say, 2 decades. Like earlier we used to have like one CPU. Now you're talking about integrated circuits, which are like a million CPUs integrated together, right? So now computation and storage is not a problem. The problem is the imagination of what you can use this technology for, right? This is where the entrepreneurship mind comes into picture, and each one of you as an engineering student have to develop that entrepreneurship mindset. Technology is there, computation is there, storage is cheaper, and most of it is even open source. It's left to your imagination what problem you want to solve using these technologies. So typical big data architecture. So let me jump into this one here. So this is how big data is positioned in any organization. This is how your machine learning and AI and many other digital tools are deployed. So you have like different data sources. You keep storing them in the big data lake, and then you have different applications which can consume this data, train themselves, and then help businesses either make decisions or manage operations. Also they can lead to different applications, like consumer applications could be like things like Uber or Ola or any of that. See why, for example, I'll tell you how Uber is able to tell you that it can reach you in 45 minutes. It uses big data. It basically looks at all the data till that point. It also applies a lot of external factors, like is there a rain happening outside, is there a protest happening outside, or is there a road work going on. It considers all that and then tells you I'm going to be at your door in 45 minutes. And it's a great example of how big data is used in an app like Uber or Ola. Okay. In fact, most of the predictive maintenance, preventive maintenance in the mechanical industry leverage this big data to be able to foresee any production issues. Okay, and fix them well in advance. Okay. All right. Again, if you do not understand the big full architecture, that's absolutely fine. But I would like you guys to develop this mindset of digital applications, and depending on your area of interest, you can deep dive. Somebody may be interested in like building apps, that's fine, they can deep dive. Somebody may be interested in managing this data, that's fine. And if you are interested in, let's say, IoT, streaming information becomes important, so you can deep dive into it, right? And it's not like all of you will become expert in all of this. Keep that in also mind. You need to choose your expertise and then deep dive. Okay, or you can be on this side where you consume the applications, not necessarily build them, right? So all of us have different roles. Either we consume or we build, but we need to have a very clear awareness of digital revolution which is happening as an engineer. All right, so these are like different open source and as well as proprietary tools available in the market. So I'm pretty sure you have heard all these names like Hadoop and Cloudera, MapR. Yeah, I mean, just go Google big data tools, you'll get all of this. And all of this, the good news is they are open source, they are accessible for people like you. In fact, these are actually developed by students like you elsewhere in the world. In fact, this is what makes me sad sometime. Like you go to any other place, the universities, the contribution of those students to the open source is huge. But you come to India, for whatever reason, we do not contribute much into the open source, right? Contribution to open source helps you learn a lot while you study, right? And also going forward, most of the interviews for any job application would depend on your contribution to the open source. It has already started in many companies, especially in digital companies like Google, Apple, where they ask you what's your contribution to the open source, and you will have to prove that work, which you can't lie because somebody can go to the web and check your contribution. Right, so it's important for all of you guys to start thinking how you can contribute to the open source while you are studying, okay, and enhance your knowledge as well, and increase the possibility of landing a great dream job you may have, or getting into your own business if you like. Okay, it's important for all of you guys to be aware and stay relevant to the different tools available in the market. All right. So that's about the big data. I'm also going to talk about maybe AI a bit. Before that, again, any questions? I'm happy to take questions now on the big data. So Praveen, we can open up any questions they may have.
Madhu, I have a question.
Go ahead, Deepa.
Madhu, you said every second, every minute we are generating data. So we should also think of how useful the data is to be preserved, right?
Okay.
So it may not lead to a big data problem if it is not useful.
See, what is useful, what is useless is a function of time we are in. Meaning, see, for example, when pandemic had happened in 1920, the data which was available was felt irrelevant and thrashed because nobody used in the next 10 or 20 decades. But now that data has become important all of a sudden because there is a new pandemic, right? Similarly, social media data, the user behavior data, for example, looking at Facebook data, neuroscientists are able to tell what is the mindset of current generation, right? They are able to say that this generation is more anxious, they are more open about their social statuses, and they are also very fragile because now the depression, everything is increasing because of so much exposure, right? Now, will you call this useless data? Maybe useless for you, but useful for someone else, right? And also, it's function of time. It may be useless today, it may be useful 10 years from now to study the human psychology, for example. Okay, so that is why we will never call data as useless. We keep storing it and use it as needed and when needed. Does that make sense?
Yes, to certain extent. But if that is the case, we should go for storing all the data, right?
That's
Almost
what we
all
do.
everything possible. So
Absolutely. Yeah,
there
I
is
mean,
end
organizations,
correct.
they don't delete anything. Facebook would never delete their data.
Okay.
And that's what
Hello, sir.
that's why big data is a problem. Yeah.
Hello, sir. Good morning.
Good morning, sir.
I fully agree with Madhu that there is no question of any useless data. Like what normally say, there is no useless student also. And I want to appreciate the fundamentals in digital revolution and what is needed in the present for generation students to understand was explained, I can say, in a beautiful and excellent way. The other
Thank you,
point I
sir.
want to, I will share with all my management and also other HODs. It is very much needed, like rightly you have pointed out. We have to remove these titles of electrical, mechanical, or anything, because finally they have to have those fundamentals of core engineering added with whatever is needed in the present generation and what is going to be used for the future. I think that is the message I have got. I really enjoyed, Mr. Madhu. I congratulate you.
Thank you, sir. Thank you very much. I think very relevant, sir, because engineering in India is pursued as just a degree and way to land a job. But engineering is a creative job. It's more creative than an arts course. So
Yeah.
it's only your imagination and commitment leads you to wonderful products which you already see in the world today.
Yes, sir.
Right.
Definitely.
So
Definitely.
engineering has no
Thank you.
limit. Yep. All right, any questions? Happy to answer. If not, maybe we can quickly touch upon the last topic which I wanted to cover on the AI.
So there's a question in the chat box.
Please go ahead, Praveen.
What about the big companies misusing the data, misusing the big data?
It
See,
was
the
already
misuse,
answered.
no, I mean, anyway, take this up.
Okay.
See, the misuse happens at all levels, right? At individual level, all the way to the organization, right? So with every new invention, there is always a use and misuse. I mean, same goes with knife, right? You can use it to cut vegetables at kitchen or you can kill someone. So there will always be misuse. This is where government bodies are coming up with a lot of regulations. In fact, entire Europe is big on the GDPR right now, which is nothing but Data Protection Act, and companies are penalized billions of dollars. But yes, as an individual, all of us need to be aware of the vulnerability we all have around data. This is where banks keep saying, don't share your OTPs, don't put your personal identity in the social, media. So individuals have a responsibility to protect their data. Organizations have a responsibility. Government also has a responsibility, but it's an emerging area. I'm pretty sure there will be new policies around to prevent it, if not completely eliminate it. But it is a threat for all of us. I hope that answers the question. Any other question we have on the chat, Praveen?
As of now, no, sir. If there are any, I'll let you know.
All right, so let me then jump on to the last topic. Just give me 1 minute. Maybe I'll use this. All right, I'll just cover this quickly. AI and ML, right? So this is one of the in fact, I think I covered this for your own college in one of the session early this year. Okay, so we keep talking about AI ML, right? This is again another buzzword today. So first of all, before we go into AI and machine learning, let's understand what is data science. So data science is basically, an engineering product of how you can convert data into information, right? It's a science of converting or transforming data into information so that you can make value out of it. Okay, so that is what data science is all about. So data science, AI, ML is not new. I again want you guys, especially engineering students, to understand it's not a new invention. In fact, the first AI ML models came in 1812. Like, you can see this chart. We had machine learning way back in 1800s as well as like 1950s and 1960s. Okay. Basically, AI ML is nothing but mathematics and statistics, right? I mean, it's been there for ages, and especially country like India has contributed a lot in the statistics field. Okay. However, the timing wasn't right. While the AI and ML was there, and probably by now you understood, the fuel of AI ML is data. That is the new fuel, and that did not exist at that point in time in 1900s. So what was the point of having a car when there was no petrol, right? That was the problem. Now time has come. You have the statistics, you have the data, because in 2005, let's say 1 billion internet users were added. And then now you also have the computation, right? So think of situation. You have statistics, you have data, you have computers which are able to compute such a huge data. And that is why time has come right for the AI ML today. Okay, it's not new, but everything has come together. The data, the computation, and the statistics itself. All right. So that's kind of a brief journey of how AI and ML has evolved in the last, let's say, 2 centuries. So there are two broader branches of data science. One we refer to as business intelligence. Second one, what we refer to as artificial intelligence. So business intelligence is more focused on reporting whatever it is, right? And then maybe you can go one more step and diagnose it, right? Think of this more like a journalism. See, what is journalism or journalists supposed to do? They are supposed to report the fact. If today there are 4,000 COVID cases, their job is to report it, and that's why it's also called as reporting, right? So this business intelligence is all about tell what has happened, and also maybe to some extent why it happened. Okay. In that context, artificial intelligence is about predicting what may happen, right? Business intelligence talks what happened, why happened. Artificial intelligence, what may happen, right? So here it is not journalism anymore. It is more of an additional intelligence to predict how many cases of COVID we may get, let's say in 2 months time, right? So that is what is the difference between the two branches. One is business intelligence, artificial intelligence. Okay. So business intelligence has been there for like close to 2 decades now, very mature. Most organizations use it. And even now it is available for individuals. For example, when you open your phone tells you for last 1 month how much calorie you have burnt or how many steps you have taken, how many kilometers you have walked. That is nothing but reporting at the individual level, right? Artificial intelligence is all about if phone telling you whether you will have any health issues in the next month. All right. And as you can see in the X and Y axis here, obviously the value increases with AI, and also difficulty also increases. Okay. Okay, so these are like some sample examples of what business intelligence can do. Usually it's in organization shown in the form of charts and graphs of everything which is happening on the business operations. And this has become more relevant as the organizations have become much bigger and scaled and global in nature. Humanly, it's not possible for, let's say one CEO to, manage hundreds of thousands employees. So this is where BI, business intelligence, help leaders monitor the situation, make right decisions, and also get a full big picture of what is happening. Okay, so this is, for example, some real examples of BI. Anyway, I need not go there. So now let's jump into the AI, right? So before we go to the AI, it's important to understand what is intelligence. See, again, I encourage engineering students to understand meaning of words. Very important. See, we all know artificial intelligence, but nobody probably have spent a second understanding why it is called artificial and intelligence, right? Many people, for example, Hadoop is nothing but an elephant. Elephant represents big, and that's why Hadoop is used for big data. So look for the meaning of these words. They are very interesting. Amazon is because Amazon means something big. It's a forest, right? Always develop this habit of understanding the meaning of these words, right? Coming to artificial intelligence, why it is called artificial intelligence? It's an artificially created human intelligence. Okay, that's why it's called AI, artificial intelligence. Why it's called machine learning? Because we are letting machine learn based on the input data. Anyway, we can deep dive into it, but important to understand the meaning of these words, and they say a lot in the word itself. So, coming back to the intelligence, right? We talk about artificial intelligence, which is artificially created human intelligence. So let's also ask ourselves, what is human intelligence? See, human intelligence is nothing but it's a collection of memories, right? The memories could come from teaching, could come from your own experience, could also come from some references what you may have seen or read and things like that. So end of the day, it's a collection of memory in your brain. So if you're able to add, let's say 2 plus 2 is equal to 4, either you have done it or you have learned it and it's memorized in your brain. Okay. So now imagine all that experience is available in the digital form. Okay. Maybe I'll take one, a real life example. So assume you go from college to your home every day. You were able to do it because you have done it in the past, right? For the first time, probably someone had to tell you how to go, but second time, third time, you already know how to go. Okay. Imagine now your phone knows that route as well. If it's GPS enabled, it exactly knows from your home to college how you can go. What is the best route? And that is what we call as digital experience now. Right? Imagine in company, in an organization, an employee is doing XYZ every day. And if he's doing it in a computer, he's leaving a digital footprint there. He's opening a screen, he's entering some data, he's pushing some button. It all becomes like a recording. And that recording is nothing but the digital experience recorded in different forms. Now, imagine we have all the digital experience and we are going to feed it to a machine, and the machine can learn just like how humans learn. Okay. So again, technically, if you deep dive it get really complex. So anyway, I before we make it very complex, important for you guys to understand superficially so that depending on your interest, you explore. You need not be an expert in everything, right? Don't attempt that. Don't try to be an expert in everything. That can only land you a good job, but you may not be able to create something new. For you to create something new, deep dive is always important. Okay. All right. So that is why artificial intelligence is referred to as an intelligence created artificially, leveraging digital experiences. Okay. Coming to the types of AI, right? So there are broadly two types, machine learning and deep learning. Again, a lot of people interchangeably use these words. Somebody say AI, somebody say machine learning, somebody say deep learning, somebody say neural networks. It's okay if outsiders say a number of things, but as an engineer, you need to have a good understanding of what is what, right? So you need to always remember data science is the umbrella under which you have artificial intelligence. Within artificial intelligence, there are different types. One is machine learning, could be deep learning, neural networks, so on and so forth. Okay. And the difference between the traditional statistical model and machine learning is just that statistical model always gave you one static equation which was used for predicting anything in the future. Now with machine learning, that equation is very dynamic. With the new experience or new data coming in, it can adopt itself, right? It is just instead of a static equation, it has become a more dynamic equation. Okay, so that is why that is the kind of difference between a statistical model versus a machine learning model, which can continuously run with the new data and new rules. Okay, and also within machine learning, there are broadly three types. One we know as supervised, second unsupervised, third is decision tree or reinforcement. Okay, supervised is all about you know what you want to predict. For example, you want to predict mileage of a given car, right? So that's a very well supervised problem. That's why it's called supervised. You know what you want machine to learn. Unsupervised is something you exactly don't know what to do with the data, but you have a bunch of data. So just feed the data. It tells you if there are any insights in it. For example, let's say you feed entire Bangalore population data into the machine learning. It may tell you, 20% are students, 30% are software engineers, another 20% are retired employees. It basically looks for patterns, right? There you may not have a specific problem to solve, but you're looking more for some additional insights. That's why it's called unsupervised. And the third one is more of a decision tree, where at any point in time you want to make a decision with multiple options. This model can help you optimize your best decision, or the reward or the outcome from that decision. Again, it's okay if you don't understand. I'm not expecting all of you to become machine learning experts, but as long as you understand what it is, how it can be used, I think you are good. Okay, so that's typical machine learning types. So now you may also wonder how these are built, right, in organizations. So many startups are running in Bangalore, so you may always wonder how these are built. Okay, so typically an analytical model is built using this life cycle process. Usually it all starts with the business requirement. For example, let's say your business problem is you want to predict the mileage of a car, so that becomes your uh, requirement. Then obviously for machine to be able to learn and predict, you need data. So you may ask, okay, give me the mileage data of last 1 year, right? Assume if you want to predict the mileage of a car, you want to know how much mileage it has given in the last 12 months, right? So that's what we call as data collection. And then obviously you want to clean also, right? Because most of the data may not be relevant for the problem you are trying to solve. So assume you are trying to predict mileage, and if you add 2020 data, 2020 data by any standard is not a good data, because there was no traffic in the road, right? It was COVID and it was all locked down, and people could speed at unprecedented speed, and the mileage was obviously better. But is that a data I want to make my machine learn? No, because that's not reality, right? Once the traffic resumes, your mileage would drop again. So that is what we mean by cleaning up that data. And then you also do some analysis of trends and patterns with that data before you kind of build a model to predict, right? So this is the step where you actually build a model. And then once the model is built, kind of test it and then deploy it. So a typical life cycle of building an analytical model. So that's why people keep saying the data scientists only do 20% of the job. The remaining 80% is actually done by a lot of other roles in the organization. Okay, so always keep this in mind. It's not that one data scientist does everything. It's like many people come together to build one solution, right? That's why these are called organizations. An individual is not an expert in everything, and if he is, maybe he can never build something which is scalable, right? So you need to start think of teams and skills when you want to build a product. So again, important to understand the words here, right? Emphasizing on the meaning of words. So we keep saying AI model. Important to understand what does the word model mean, right? We use the same word in fashion industry. We use the same word in car industry. A model is nothing but a representation of a bigger population, right? For example, the mannequin you see here is actually nothing but a model, and it is created looking at the local population. For example, in India, this model may have a height of, let's say, 5'7" or 5'8", because that's the average height. If you go to North America, this may be made at 6 feet, because there the height could be 6 feet on an average, right? A model, always keep in mind, is a representation of a bigger population and used to give you a directional sense. For example, let's say you have a mannequin wearing a dress. You go take a look at it. and you can kind of relatively say whether it would fit you or not, because you know that model is like, exactly of your height. So you can kind of sense that, okay, it would fit. Assume if you are slightly taller than the model, then also you get a directional figure saying, okay, this may still look good on me, right? So that is why models will never be 100% accurate. Models are not meant to be 100% accurate. They are meant to be giving you a directional indication, right? And if you make it 100% perfect, then you will have as many models as the population itself, right? Keep this in mind. Again, I know it may be kind of overflowing your brain, but understand the word model and why it's used in the AI industry. Okay. All right. And yeah, once you kind of have business problem and all that stuff. So these models are chosen depending on the problem you are trying to solve, and then once you choose a model, you kind of train it and test it and all that stuff. Again, I wouldn't emphasize too much on by hearting these models, because they are changing like every day. It's like, learn to drive, not necessarily learn the route itself, right? As long as you know how to learn how to drive, route can change depending on the destination, right? Today you may want to go to place B, tomorrow place C. What do? You use the Google map. Similarly here, go to Google, search for the model. At that point in time, whatever is good model, Google will only tell you, as long you know what the model is, how to apply it. Okay, so I wouldn't stress too much on. In fact, a lot of people ask me what's the best model for, natural language processing, or, voice analytics, or computer vision. My answer is, best is a function of time. Today, what's best? Probably 1 month from now, there is a new model which is much better. Okay, so that's about the model. All right. So other trends which you may be, wanting to be aware on the AI is, you should be aware of open source. Definitely as a student, you should understand what is open source, who is building it, how you can take part in it. In fact, if you do not take part in open source as an engineering student of this era, you're losing big time. Trust me on this. When you go for a job interview at good companies 4 years from now, they would ask for your contribution in the open source. Okay. Similarly, let's say you want to build a project in your engineering and you want some additional skills, go for crowdsourcing. There are platforms where you can hire skills at an individual level, and you can also be part of that, and service to different people. Assume you are good at, let's say, building AI model. You can actually register yourself as an expert. People will reach out to you when they have a problem, and you can even make money out of it. In fact, many students in other countries make a good amount of money through being part of crowdsourcing. So it gives you experience, it gives you money, it helps you apply what you learn in the school. You can't ask for more, right? I mean, it's like, the best you can get today. And then there is also huge work happening in the OpenAI space, where a lot of research is happening, funded by Microsoft or Elon Musk or many of these people. So you need to be aware what's happening in the OpenAI, and again, use them for your applications, contribute to them, and be part of this OpenAI community, which would become future very soon. Okay. So I think as a student, if you can, develop this habit of, staying relevant to any point in time, I think it will help you in the long run. Okay. All right. Any questions? I think I'm kind of almost done with the content I wanted to say today. Open for any questions you may have. I ask any question like, IoT I have not covered, or blockchain I have not covered. Feel free to ask any other questions which I may not have covered.
I have allowed the students to unmute, sir. They can ask any questions.
Sure.
Yeah.
Sure, Praveen.
Students, you can go ahead and ask your questions.
Madhu, I have one simple question.
Sure.
You
Right.
spoke about industry revolution and your digital revolution and all. What about the basic necessities like we have energy crisis, we have water crisis, temperature is rising, greenhouse effect, all that. Why don't you digitalization can help towards these problems which the world is facing right now?
No, absolutely. I mean, digital is certainly helping in different aspects. For example, the digital currency is helping reduce the number of paper currency we have, right? So yeah, I mean, again, it's a great opportunity for all of us at all the levels to leverage digital and solve some of the most complex problems of the world. One of that is also the ecological disaster what we have. Yeah, I mean organizations are doing this. In fact, paperless is a great initiative every organization is taking today because trees are cut just to make these papers, right? Just going by digital, you save so many trees. Absolutely right, Deepa. So technology can help solve some of these problems.
Uh, Mr. Hosadurga, thank you for your wonderful presentation, and you have opened so many misconceptions about especially machine learning, where people
Mhm.
thought machine learning is about totally mechanical, and now you have explained it wonderfully well. Um, so one thing I would like to add here is regarding open AI.
Mhm.
We are in the process of signing a campus-wide agreement for GitHub, which is
Sure.
a global platform for open source and
Very good.
crowdsourcing. And I would like to announce it in this forum that very soon, maybe in a couple of months, we will be having a campus-wide license for GitHub, where all the students can register themselves and start contributing to the open source community. So this will be a wonderful initiative for all the students and a platform for them to share their learnings and also learn from other people on the open source platform. So this I thought I would announce it on this gathering right now. Thank you once again.
Thanks, Professor. Yeah, I think very good. I think GitHub is a great platform, and all of you students should be very, very active in that, and it would really help you, succeed in the field you are in.
Sir, and there is a question in the chat box. What is
Mhm.
your comment on Neuralink?
Neuralink.
Yeah.
Sir, I think he is referring to the modification of human brains, if I'm not wrong. So again, the possibilities are endless, leveraging technology to advance humans and their capabilities. But again, and I think we have probably, as Deepa said, we have a lot of other basic problems we are yet to solve, and probably humans are not even using their full capacity even today. Forget enhancing their capacity. I think we all should focus on now the current problem in the hand and leverage humans' brain to full extent what we have today instead of thinking how we can enhance it further. I mean, that's my view.
Riddhi, you can go ahead and ask your question. Vibha,
Sir,
you
I
can
have a
also go
question.
ahead. Yeah.
Sir, how do you apply blockchain at Schneider, sir?
See, blockchain as a technology can have hundreds of applications, right? So, for example, what we apply it, one example I can give you is traceability from our raw material all the way to the customer product, right? So we have 300,000 different products we manufacture, and we may have like lakhs of customers across the world. And blockchain help us maintain the traceability, right? Blockchain is basically an immutable chain of transactions, right? It helps us traceability. That way, nobody hampers, the entire the traceability of the product. For example, the customer buying our product exactly
Sir,
know where the
is this logistic solution like in play right now? Like, are you using it right now?
Yeah, we use traceability right now. Yeah.
And I've got another question, sir.
Sure, please go ahead.
Sir, do you think like artificial intelligence becomes advanced enough to break like encryption algorithms used for blockchain, sir? Like SHA-256 advanced encryption standard and all that?
See, the breaking encryption in blockchain is a problem of how much computation you have. It's not a problem of AI, right?
Yes,
See,
sir.
basically, what is blockchain? You have hundreds of or thousands of nodes, and everybody have to give consensus for a transaction to happen, right?
Sir,
And all of them share.
I'm a technical blogger. I'm currently writing for a few blockchain projects,
Very
sir.
good, very good, very good.
So
Yeah, I think it's a
I saw
problem
your
of
website and
computation than
it
the
was
AI.
yes, sir.
Okay, so it's a problem of computation because the amount of computation you would need, it's not even worth decrypting.
Yes.
So the money value doesn't even help.
Fine.
Okay, I think
Thank you.
Riddhi has a question. Go ahead, Riddhi.
Sir, I
I
was
think that's a
wondering.
good habit, by the way. Just want to mention, yeah, blogging is a great habit. Please, develop that further.
Okay, sir. Thank you, sir.
Thank you.
Vibha, you
Riddhi,
can go ahead and ask your question.
yep.
Sir. Good morning, sir. I'm Vibha from AIML.
Hello, Vibha.
Yes, sir. I wanted to ask, could you just explain how cloud computing works when it comes to storage of data for deep learning?
Okay. So first of all, separate deep learning and cloud. They are two different aspects, right? So cloud is all about storage and computation of any data. It need not be for deep learning or machine learning or ERP, right? So cloud, see, earlier, I mean, 5-10 years back, both computation and storage were very expensive. Okay, and it was not even affordable for many organizations. So that is why they were limited in the application. Now just think of it like Bangalore real estate. No, everybody wanted to have an individual plot and a house, but becoming unaffordable, right? What happened? We started with the apartment complex where you build a big building leveraging very small land, but you can have hundreds of houses. That is precisely what cloud is all about. It is about somebody has built a big storage and computation with economy of scale, which individual organizations can rent. Think of cloud as renting an apartment in a big complex, and the whole proposition is cheaper because economy of scale has happened. Okay, so now you can use this computation and storage for many purposes. Deep learning is one such purpose. Does that answer your question, Vibha?
Yes, sir. So, and one more thing, can the like Google has a cloud platform, so can Google access the data which is in that cloud platform, which belongs to someone else?
See, within cloud, you have different packages, right? Someone can buy a private package within the Google. Somebody can buy a public package. Depending on how much money you're ready to pay, the privacy policies may change. If you want 100% privacy, you will probably have to pay money for it. So the options are there for organizations, which way they want to go. And some companies can even actually pledge their data for research purpose. So that's up to them.
Okay, sir.
But
Thank you.
technically there are options. Yeah. Thanks.
Shreyas, you can go ahead and ask your question.
Go ahead, Shreyas.
There's one more question from Dhanush. Yeah. Sir,
Sure,
can
go
you
ahead.
simplify how IoT is used in field of electronics?
Sure. So, see, take any electronics device today. Okay, think of electric cars, right? It's an electronic device, right? So now imagine cars have these IoT sensors, right? Let's say you are driving at 50, 60 kilometer speed, and then the car is sensor enabled. It keeps streaming, the information to, let's say, whoever needs to consume that information. And assume an accident happens, unfortunate. Now, all of a sudden, this sensor can communicate to nearby hospital to send an ambulance to this location, because sensor can send the location, it can send the severity of the accident, it can also send how many passengers were in the car. Then ambulance gets the message real time, like in a fraction of a second, and it can rush back, right? So the applications of IoT, whether for an electronic device or a mechanical device, is up to your imagination. So, but technology can help with whatever you want to solve. Does that answer your question? See, don't have this mindset that technology can only solve certain problem, right? You as an engineer should know that technology solves the problem which we want it to solve. It doesn't solve its own. Okay, hope
Yes, sir.
that answers. Yep.
Yeah. Snigdashri, you can go ahead and ask your question. And Aditya, you are next. Be ready.
Good morning, sir.
Good morning.
Sir, actually, as we have started our topic with data science, sir, after the invention of quantum computation, I've heard that there is a lot of problem for our data and there will be a lot of insecurity in future. So there are even efforts of making quantum internet. Do you think this will bring a revolution in the world of internet, sir?
See, any enhancement in computation obviously would bring revolution, and quantum computing is just an enhanced computation. Okay, with more computation, obviously it would bring good things as well as bad things. It can revolutionize for sure, but applications, if they are made with good intentions, they will be good. I mean, this is where engineers have a big role to play. Always, have good ethics around whatever you build, right? While technology can give you the power, it's just like knife, as I said. You can either use to kill someone or you can use to cut vegetables, right? So up to you what intention you have when you make the product. Okay, but just to answer your question, quantum computing definitely gives us more power when it comes to computation. It can compute things which otherwise humanly as well as with other computers was impossible. Right? Imagine, when you are researching on a clinical data, which could be zettabytes every second, right? You have zettabytes of cells in your body, and imagine that multiplied by 7 billion people. Only quantum kind of computer can solve that problem or process that much of information and compute.
Sir, do you think there will be a day when we will move on to quantum internet, sir?
See, there's nothing called quantum internet. Quantum is a computation, right? Internet is a network of different computers, right? If you are saying we're going to have a network of quantum computers, probably a day would come, maybe, I don't know, 50, 60 years, where quantum computing will become like your desktop. That, anyway, I mean, no point even thinking about it, because there could be even bigger than quantum. And then, humans keep incrementally evolving, right? 100 years from now, quantum may be in your mobile. Anyway, I mean, see, don't worry too much, what disruption can happen in the really long run, because difficult to predict with so much happening, so much changing. Difficult to say whether, quantum would be disruptive or constructive, or will anything much powerful than quantum itself would come.
Yes, Aditya, you can ask your question.
So when we have a computationally demanding task, we make use of cluster computers, and then we partition the huge task into smaller tasks and then give it to the individual computers to work on. So my question is, do you think like AI will be able to come up with algorithms that the same huge ginormous task, which required a large, a heavy hardware specification, to be able to run on devices with low-end hardware?
Sorry, can you repeat the question again, the last part? I mean, if you could repeat the question, that will be helpful.
Sir, for like computationally demanding tasks, can AI help change, like can it develop an algorithm such that even such heavy tasks work on low-end hardware? Can it come like say multiplying two 40-digit numbers is very computationally intensive for a home desktop environment. So like
and that
home
is
PC can't
precisely
do
what
that.
cloud does, right? I mean, that is precisely what cloud does. Cloud basically combines multiple smaller computers and make it like a big computer.
Yes, sir. So I'm saying, can AI make it such that that huge task which couldn't be done on the home PC, like in the future it will be done on the home PC by using different methods? Like
Yeah. I mean, technically, it's already happening. It's not even a question of whether it can be done. It's already happening. In fact, there is a new element to it. It's not just AI ML. It's also blockchain getting added. In fact, you may have heard of um, you know tokens like Cortex. Cortex is basically an AI ML blockchain platform. Similarly, you may have heard of Storj. Storj is nothing but a blockchain of storage from different computers, which can be interchanged or exchanged as needed. Right? I don't see it as a problem. It's already happening, and that is the future, anyways. Where you basically what we call as divide and rule. Any complex problem has to be divided into smaller chunks, and then all of that together can solve the problem. And AI ML can help manage that, how much to go where, and manage the situation. The whole division can be managed by AML. It's already happening. That's how cloud work. That's what we mean by scalability.
Okay, thank you, sir.
So basically, you're essentially asking, can it be made intelligent? Yes, they're all very intelligent systems who exactly know how much computation need to be consumed at any point in time.
Yes, sir. So I just wanted to know if it could be done efficiently enough to run on a home PC.
Yeah. So if you are on a network and if you are able to divide the complex task into small chunks and leverage different computers. In fact, that's how BitTorrent and all of this would work. It's already it's an old concept. Okay, read about BitTorrent, read about Storj, read about Cortex. You will get an idea. Okay, we can move to the next question.
Shreyas, you can ask your question. Shreyas, you're not audible.
Now?
Yes,
yeah,
now
we can hear you.
Yes. So my question was, as you said earlier, in the near future, we would end up generating zettabytes worth of data. So setting AI aside, do you think the current server designs would be able to process such vast amounts of data?
I mean, when you say current, there are different levels of. You may want to go on mute. Yeah, so even currently, there are different levels of maturity across organizations. Some are able to manage, some are not able to manage. So I don't think we are all across the world at the same maturity to process big data. Some are getting there, some are already there.
So one more question I have.
Mm-hmm.
So do you think with the success of AI, quantum computers could be generalized for household use as well?
See, only time will have to tell, because see, something becoming a household is a function of organizations. How much, see, for example, if it is patented, right, everybody can't use it till a point in time, like 20 years from now and things like that. Can it be made a household device? Technically, yes. In fact, technology is evolving at a very, very fast pace. It can be made available, but the interest of organizations could be different. They may not want to make it at the individual level. They may want to make it premium for the businesses to use, not at the individual level. So, as I said, technically possible, but commercially, organizations may have a different intentions.
Thank you, sir.
All right. Is that it, Praveen? Any other questions, or if not, we can probably.
There aren't any, I think, sir. If there are, I
Okay.
think we can just ask the students again. If there are any questions, you can please go ahead and ask.
All right, no worries. Anyway, I think we have also used most of the time. And again,
Yes, sir.
good for all of you to develop this habit of asking questions and staying curious, because with so much change happening around you in terms of technology, the best way to learn is by staying curious and asking questions, right?
Yes, sir.
Asking
And
questions actually not only make you think, also it helps you dissect any problem, and it may get you your own answers as well. Yeah, go ahead, Praveen. You're
yes,
saying something.
yeah. On behalf of BNMIT, sir, I take this opportunity to thank you for a wonderful session on digital revolution to data and to AIML. You have covered most of it, I'm sure. Thank you so much for taking your time and talking to our students. And with that, I again thank you for patiently answering all the questions from the students, sir. Thank you very much, sir.
It's my pleasure, Praveen and team, and thanks for giving me this opportunity. Again, it feels good to be addressing such a large community of budding engineers. So thanks again, and wish all the best to all the engineers, and look forward for your contribution in the digital sector in the coming years.
Thank you, sir. Thank you very much.
And feel free to ask me any questions. You can connect me on LinkedIn or any other platforms, and want to stay in touch, please do so.
Sure, sir. Sure. Thank you very much
All
for
right,
being a part
thanks.
of a wonderful
Thanks, everyone.
session, sir. Yeah, thank you, sir.
Have a good day. Bye-bye.
Yeah, thank you, sir.
Sorry,
And my
I
dear
can log off?
students- Yeah, sure, sir. Sure. Thank you.
All right, thank you. Bye-bye.
And my dear students, the feedback for the today's session I have already posted in the chat. Please go through and give your valuable feedbacks. And I take this opportunity to thank the director of BNMIT, Professor TJR sir. And I also take this opportunity to thank the additional director, S.Y. Kulkarni sir, and our dean, Professor Ishwarian Mane, and our principal, Krishnamurthy sir, and also all the faculty members who have joined a wonderful session here today. I also thank them, and all the HODs and all my dear students. I thank you once again for joining this session. And Monday will be our next session. See you at 10 a.m. on Monday. Thank you all for joining the session. And I repeat again, the feedback is already posted in the chat. Please go through and give your feedbacks. Thank you one and all.